Welcome to ECO Ask Why, a podcast that dives into industrial manufacturing topics and spotlights the heroes that keep America running. I'm your host, Chris Granger, and on this podcast, we do not cover the latest features and benefits on products that come to market. Instead, we focus on advice and insight from the top minds of industry because people and ideas will be how America remains number one in manufacturing in the world. Welcome to ECO Ask Why. I'm your host, Chris Granger. I'm looking forward to spending some time with you today. Pretty excited. We've been on ECO Ask Why. We've been talking about for a while lots of different things with digital twins and AI, but we're starting a new part of our series, and this is going to be our first episode. We're going to be digging into industrial control panels. So this is going to be exciting, something near and dear to electrical equipment company, to what we love, how we try to support. So hopefully you're going to enjoy this. And we're going to call this just industrial control panels 101. Pretty simple, okay? We're going to really try to understand the heart of automation and help you, if you're new to the industrial manufacturing or the electrical industry, kind of maybe break down some terms and some vocabulary that you need to know to better understand what you're looking at in the field, and also hopefully build your confidence as you move and navigate within these manufacturing plants. So next year, so this is coming out in November of 2025, sorry. But next year is our 100th year anniversary at Electrical Equipment Company. So that's a century. 100 years, we've been supporting the advancement of automation across so many industries, from textiles to wastewater treatment plants to high-speed manufacturing, pulp and paper, chemical, pharmaceutical. It's crazy. I want to start thinking about it. And this is when you start thinking about a legacy of 100 years, that tells us one thing. We've seen firsthand how industrial control panels serve as the heartbeat of modern automation. And it's really neat. I'm super excited to just be a part of it, just a small part of it. But hopefully you're going to enjoy this, because an industrial control panel, they're the central nervous system of operations and industrial manufacturing. They bring the power, they bring the control, they bring the intelligence all together, and they translate physical inputs like temperature readings or motor speeds into meaningful outputs like pump actuation or conveyor movement. So look, if you want to understand how today's facilities operate with precision, with reliability, with safety, all the things that we care about, right? You need to start by understanding the industrial control panel. That's what it's about. Okay, so we're going to kind of just break down some components as we go. Again, this is going to be a 3-part series. So over the next 2 months, we're going to be giving you more and more information here. Check out all the links, all the connections, all the ways to connect with us, because we have the experts on staff ready to come serve and to help you with your industrial control panel needs. So let's just talk about the beginning, the brains of the operation, if you will. Okay. So that's your PLCs. You may, programmable logic controllers is what that actually stands for. But when you open a control panel, your eyes most likely are going to be drawn to a rectangular device with lots of wires coming into it. There's going to be lots of little lights flickering on and off. And this is your PLC, your programmable logic controller. Okay. So it's the brains behind the system. So it's basically, you can think of it as like a rugged industrial computer built to withstand vibration, heat, noise, all the stuff that the industrial manufacturing, environment's going to put in front of it. So the PLC runs on a cycle, and basically how it works, it reads the inputs. So you got sensors and switches and instruments that are providing input data to it. Then it executes logic. So you have to program this. So this is a big part of what electrical engineering teaches you, and technicians can do this as well. So far as understanding the logic that works to understand the inputs, and then the logic controls the outputs. So this could be motors or solenoids or valves or whatever it may be. So that's what's going on here. So you have these input signals coming in, logic that's being worked through and executed, and then the outputs that are being sent to control, with the equipment that we're trying to control. So in essence, you can think of a PLC as like a decision maker. That's it. So if a sensor is giving a signal that a tank is almost full, the PLC's logic may stop a pump or close a valve or open a valve, right? Just to control that. Or if you have a temperature rising too high, that sensor within the logic may trigger a cooling fan. or send an alarm through a human machine interface, an HMI. We're going to talk about those as well as we dig into this. But that's how it works. So modern PLCs today, they used to be just standalone systems. And they still have some of those where you have a standalone on a piece of equipment. But most PLCs now are networked. So this brings you a whole nother level of communication between systems. This gives you the ability to do remote diagnostics, and you can integrate it with your plant SCADA systems. So the PLC is not just a standalone anymore. So whether you're standing in front of a piece of equipment, or like a multi-bay MCC, or even at home now through remote monitoring, it's you can bet pretty sure that a PLC is doing a lot of that control. Okay, so that's a big piece of the components that we want to make sure you understand. Again, with a PLC, you also have your different modules, your input modules, your output modules, your different types of temperature reading modules. You have your communication modules. So there's so many ways that you can build onto the PLC now. And again, we support several manufacturers out there. So if you want to find out what manufacturer we serve in your area, just reach out to us. We'd love to have a conversation with you. We have experts across all our geography. So if it comes down to a PLC and you got a question, I can guarantee you somebody, electrical equipment company, is going to be able to answer it in a confident way, or at least point you in the right direction. Okay. Now, you got the PLC doing that. Then you have to think about, well, how do we as operators interact with the equipment? Well, we need a window to do that. And industrial control panels, that's often the HMI, or the human machine interface. We love our acronyms, right? That's the way it works. So the PLC handles the logic. The HMI is the operator window into the process. So if you walk up to a panel, typically you're going to see some type of touch screen with gauges or buttons or actual process graphics. That's the HMI. That's what you're looking at. It's giving you feedback. It gives the technicians and the operators real-time visibility into what's happening. Okay, so it gives you machine status, may show you different types of alarms. It could show you some big, key performance indicators like pressures or flows or speeds. But a good HMI, what I like the most about them, they mirror the process. So you can walk up and you can visually connect with what you're seeing on the screen to what's happening on the machine itself. I mean, that's really the beauty of it too. You don't have to think about, well, okay, I wonder what this is here. No, you can see it on the HMI and then look and see that equipment working. And with an HMI, you also have the ability sometimes for control. You can start or stop a process. You can reset faults. You can adjust set points, all without opening the panel. So really gives you a safe way to do this. So a lot of times operators rely on color-coded indicators, like green for running or red for stop or yellow for a fault, to help them make quick in-the-moment decisions. So it's the perfect blend of automation, which is important, but also that human oversight. We cannot miss the human element and how important that is in an efficient industrial operation. All right, so now, inside of an industrial control panel, what else are you going to have? Well, you're going to have power distribution. So this is kind of like the lifeline. So every control panel must safely manage and distribute power. So this begins, easiest way to think about it. What's the incoming source? Need to understand that. And then it flows through a series of key components to help ensure reliability and protection, because you don't want anybody to get hurt, because in any industrial control panel, you can get hurt. So the first thing I always like to look for, if you walk up to an industrial control panel, particularly if you're going to be working in it, is understand what a disconnect is. Just understand that. This is like your master safety switch. So look for the disconnect handle. Usually it's mounted on the door of the enclosure, okay? And it's the first step for safety, because you want to be safe. The disconnect gives you a mechanical way to cut off the incoming power to the rest of the panel. So if you're going to be doing any maintenance or troubleshooting, it's important to make sure that we're de-energized, okay? And look, a clearly labeled disconnect isn't just a good design choice. It's actually required. It's a safety standard. So NFPA 79, you have UL 508A. They have these governing standards so far as panel construction. So just be careful. Like, you never want to go inside of a live industrial control panel unless you're fully trained and completely understand the risk points involved. So to disconnect, easy way, walk up to a panel, understand what that disconnect is, okay? All right, second piece of power to consider are just your transformers, right? You have to be able to convert that voltage into a usable form. So industrial facilities usually have higher voltages coming in to run their equipment. You can have 4160, you can have 2300, you can have it down to 480 volts. That's pretty common. But control devices are not going to be hooked up to 480 typically. Usually, they're going to work at lower voltage, like 120 volts AC or even 24 volts DC. So how do you do that? Well, you have to get some transformers. And no, we're not talking about the movie. All those movies were awesome. No, this is a different type of transformer. So when you open a panel, you'll usually see a metal core component mounted at the low side of the back panel. Usually transformers are towards the bottom. Why? Because they're heavy, right? These things got some weight to them. So what you'll find with these devices, usually they're control transformers is what they're called. So what they're supposed to do is to step down the voltage safely so that you can utilize it internally. And so understanding this voltage flow is crucial. So you got your high voltage in and you got your low voltage control power out. So it's just a quick way you can open up. You can see, okay, here's my power coming in. It's going through the disconnect. Maybe it's going through a breaker. At what point does it get broken down? That's your control transformer, your transformers, okay? All right. Now, the third from a power standpoint that we want to talk about are your power supplies. Because you got to be able quite often to get DC conversion for your field devices. So after your transformer, your power supplies can convert that AC, typically it's about 120 volt. That's usually what you're going to see, into a DC voltage, like a 24 volt DC, that's highly utilized in industrial control. And this low voltage output power helps your devices like your sensors, your relays, and your PLC input cards. All right? So when you identify a small metal box with a cooling vent, maybe like an LED indicator that's labeled 24 volt DC output, guess what? You found the power supply. Hallelujah. So it's the unsung hero that ensure everything kind of talks correctly without lowering the risk of shock, right? So this is very important just to understand what to look for from a power standpoint. All right. Now, let's just kind of walk through one-on-one. You walk up to a panel. How do you quickly identify what you're seeing? And look, this can be intimidating. I remember when I was first into the industry and I would walk up to these panels and I would be like, I don't even know what in the wide world of sports is going on here, right? So it's okay. It's good to have a healthy respect for what's going on inside industrial control panels because they can hurt you if you're not careful. So if you're new to automation, this is maybe helpful for you. But because just know this, once you understand the structure, it starts becoming to make a lot more sense, and it's just like reading a map. Okay, so here's a very simple but systematic way to approach it. Number one, start with power. I want to know first out the gate, what can cause me the most harm? And that's the power. So identify the incoming power, the disconnect, follow the path. Again, it could be through a circuit breaker or through some type of fuse block to understand where it goes to the transformer and the power supplies, looking for those fuses, those breakers, all those things that isolates the different circuits. Try to understand the power flow, okay? Then from there, you may want to try to locate the brains, like find the PLC. Usually the PLC, quite often, is just in the middle somewhere because you have a lot of wiring coming to it. Lots of the time the wiring is coming in from the bottom. So just look for there. You can look for labeled inputs and output terminals, and then check the communication ports as well. You'll see different types of communications from Ethernet to Profinet to serial. I mean, all these different types of communication protocols used for networking. And then look for the interface. Like, how am I going to understand what's going on? Usually this is like an HMI screen. Lots of times they're cut out in the front door, or sometimes they'll even be remotely mounted terminals. Whatever the particular setup is, I've seen HMIs that have connected to where they mount to the outside, so you don't actually do a cutout. They're just bolted to the outside. There's lots of different ways to have that. So once you have a chance to see the HMI, then see what it's telling you. See if it's showing you pressure or temperature or speed, anything like that. Just understand what's going on inside from the HMI. And then the organization overall, just as you start working inside different manufacturers and different manufacturers of equipment as well, you'll notice patterns. And you'll usually see a pattern layout for efficiency. So you'll see power components at the bottom because they're the heaviest and create the most heat. You'll see control components towards the middle. You have I/O terminals or field connections usually are on the top or the side. So all that stuff is pretty standard. And then you'll hear some stuff called DIN rail. So DIN rail is nothing but a piece of metal strip where these components can snap to it. So if you see like a metal strip on the back plane, that's usually what you use to connect the components directly inside the control panel versus like bolting them on directly. And if you do that, you also notice usually if you open up a panel, you'll see these things. They're rectangle. Lots of times they're gray. They're long strips. And it's like, what is going? It almost looks like a little channel or something, right? What that is wiring duct. Okay. And that allows you as a panel builder to keep your cables, all your wiring completely neat and routed and labeled and out the way. Or else if you didn't have that, you'd have wires everywhere. It would be crazy, right? So then the last thing, always check for safety and documentation. Like check your grounding bars, check to make sure everything is clearly labeled. Reference to wiring diagrams, right? Usually you can often find the wiring diagram when if you open a control panel door, most often there's a sleeve on the inside of that door. Check it out right there. Because those blueprints can be so invaluable, particularly when it comes to troubleshooting. All right, so you'll see technicians. Technicians know where these drawings are. I can promise you that. But the more you practice, my encouragement to you, the quicker you're going to develop an instinct for identifying the panel anatomy, okay? And over time, you'll just be able to quickly identify power flow, spot faults, or identify missing termination. It's just going to come natural. It's just one of those things that just comes with reps, okay? So as we think about this, again, if you want to have a framework for reliability within an industrial control panel, it all comes down to organization and maintenance. Because the most advanced automation system is only as reliable as the installation and documentation that comes with it. So a well-designed control panel, I love to see brand new control panels because they exhibit craftsmanship, clean wiring, consistent labeling, very logical layout of the components, and that is going to just produce a very robust and reliable industrial control panel. And some key elements to think about when you're thinking about longevity and maintainability. Think about your wiring duct. We've already talked about it once, but that wiring duct is important. You want to make sure everything is organized, protected. You also want to standardize on DIN rail. That just makes easy for mounting relays and breakers and terminal blocks. Take them all so much easier. Then you have to think about your fuses and your circuit breakers because you want to make sure that you're protecting for your overcurrent conditions, right? So this is very important with electronic devices. You have your overloads. Got to be super careful about taking care of your motors. So the overloads are so important. So your motor tripping currents, if they're drawing too much current draw, you want to be able to shut them things down safely and not cause any harm. Don't want to burn up any motors. Overloads are important. Then you have your grounding system. Why is that important? Because it protects your equipment from stray voltages, and it also protects your people. Okay, and then those accurate drawings. Really, can't emphasize this enough. Don't miss that part. If you're working with a vendor or a manufacturer or whoever's bringing in some equipment, you need to have the drawings. The drawings are going to be your Bible that you go back to when you're trying to understand what's going on or you're trying to troubleshoot. You want to have accuracy there. And here's another thing to consider. As you change equipment or repair equipment, update the drawings so that the team will understand what's going on if they have to work on it in the future, okay? So ECO, we've long emphasized fundamentals because they make a tangible difference in how a system lasts, the longevity, and ultimately how quickly a tech can get that equipment back online. And that's what it's all about. We want to get you back working and understanding. So again, our history of supporting industrial automation, almost 100 years. It's kind of crazy to think about. And that's really we've built it on partnerships. We work with some of the best manufacturers on the planet. We work directly with engineers, OEMs, and manufacturers directly to design, build, and really maintain reliable control systems that can stand the test of time. And we feel like this is pretty simple. If you want to go fast, just go by yourself. But if you want to go far, bring other people along. And that's the value we bring at Electrical Equipment Company, because we can go far by walking alongside you to sharing our knowledge, to sharing our connections with industry of different manufacturers, solutions, and help prepare and empower the next generation of automation professionals out there. So I'm telling you, today, the same principles that guided ECO in its early years, so far as being steady, being true to the craft, being innovative, still drive how we design and support manufacturing today. And control systems are just near and dear to our heart. So whether you're working on a legacy MCC or troubleshooting a network PLC system, or trying to just really get a better understanding of your 508A compliant panels, our commitment is not changed to help keep America's industry running safer, smarter, and stronger. That's what it's all about. So hopefully, if you start thinking about this, again, the industrial control panel, it's not just a metal enclosure with wires. No, it is core to the automation system. And we need to hopefully now you maybe have a little better understanding of what to expect when you walk up in to look at one. So if you start thinking about like intelligent PLCs, HMIs, the infrastructure, it really brings it all together and brings it to life. So hopefully now you have a little more confidence that you're not just looking at hardware, you're seeing decades of engineering evolution and craftsmanship. And hey, we've been doing it for 10 decades here now. So we're pretty excited about that. And if you need help and you need support, please reach out to us. There will be links in the show notes. There are going to be links in the video, wherever you're finding this at. We want to be able to connect with you. We have labs where you can come in and test some of these devices directly. If you just have a panel that you need support with and you're just not sure what's going on with that panel, we have experts who are willing to come out to your site and to help come alongside you to build your confidence so that when you open up that panel, you know exactly what you're looking at. Okay. So we're here to help. We're here to serve in a mighty way. And again, coming up in the next few months, we're going to be giving you hopefully even more insight and encouragement into industrial control panels. So if this has helped you or encouraged you in any way, please share it with others, particularly those that are newer to the industry. And then you can go to ECO Online, that's EECO online.com. Love to connect with you there. That's where you can connect with all our resources, all our experts. Again, we have labs across all our geography. So if you want to actually schedule some time to come into one of our labs to do a demo, to just walk through some equipment, maybe you want to just sharpen your skills in some areas, we have that capability as well. And then we always work with vendors to do training. So if you're interested in just building up your training skill set, go check out our training resources as well, because that could be a great way to just enhance your confidence and your ability in serving industrial manufacturing in the future. Okay. So if you wouldn't mind, give us a rating and review. That stuff does help for sure. But the big thing is just check us out at ecoonline.com. Follow us on LinkedIn. We try to put a lot of resources there as well. But really, we're all about that one-on-one connection, because again, it's not just about going fast. It's about going far together. So that's what we're all about. All right. Well, have a great day. Thank you so much for hanging out. And remember to keep asking why. Thank you for listening to ECO Ask Why. This show is supported ad-free by Electrical Equipment Company. ECO is redefining the expectations of an electrical distributor by placing people and ideas before products. Please subscribe and share with your colleagues and friends. Also, leave comments, feedback, and any new topics that you would like to hear. To learn more or to share your insights, visit ecosky.com. That's EECOASKSWHY.com.